On today's episode, we're going to guide you through how to upload a Basemap and how to go ahead and configure it so you can bring the vehicle to us. There's a few things that you have to be mindful of when you are installing the new ECU, when you're configuring the ECU. Even if you have a decent Basemap provided, we'll go ahead and let you guys know what you need to do step by step in order to avoid any sort of pitfalls and potentially, destroying computers or ignition coils. So on the dyno here today, we have a relatively rare car. It's an R32 GTR V-Spec 2, if memory serves me correct. It's completely bone stock. The only thing that's done to it is a Tomei titanium downpipe and an aftermarket exhaust. I believe it's a Power Muse 4-inch exhaust. So we're actually doing some developments in collaboration with ECU Master on their new EMU Pro adapter for their EMU Pro-8 and 16. So this is the perfect time to go ahead and kind of show you the ins and outs of uploading a Basemap and going through the steps. Depending on the ECU that you get, some of them do sometimes come locked. For example, Lake ECUs, you have to go ahead and reach out to the seller that you purchased it from and supply them with the serial number. They'll go ahead and generate a passkey for you. But the majority of the standalone ECUs, including the ECU Master Pro-8, comes unlocked. But the one thing you also have to be mindful of is ensuring that you're on the most up-to-date firmware. Some firmwares do have bugs that have been fixed over time, and depending on when you bought the ECU, if you bought it a year ago, it probably has an outdated firmware. On this particular Pro-8, I'm using an experimental firmware, so I am expecting some issues and some potential bugs, but as a tuner, we go ahead and we have access to these beta firmwares. So ensure that your ECU is unlocked. If it isn't, reach out to the seller. If you purchase the ECU from us, hypothetically, let's say you purchased a Link ECU, we will go ahead and save the serial number, so when you do give us a call, it's a 5-minute process. We'll send you off the passcode key and you can go ahead and upload that. Before you go ahead and install the new ECU, make sure that you unplug the negative battery terminal on your battery. You don't want to go ahead and accidentally create a dead short when doing some stuff. So we'll go ahead and show you what to do and how to do it properly. So yeah, stay tuned. So here we're just undoing the negative. On some vehicles, your battery may be located in the back. Just make sure you remove it, tuck the cable out of the way, just so if you are moving around, it doesn't touch the battery negative terminal and provide power to the car. We'll go ahead and move on to removing the ECU, installing the adapter, plugging in the ECU, and then plugging the laptop in. So depending on the chassis, sometimes the ECUs are behind the glove box. For example, on the Mark III Supras, they sit right above the glove box. You may have to go ahead and remove this glove box in order to be able to access it. In R32, 33, 34s, they're on the left side kick panel. Obviously the kick panel is already removed. It's typically held on with 3 or 4 bolts. This one only has 2 holding the ECU on, so we'll go ahead and remove these bolts. There it is. We'll go ahead and unbolt the ECU header from the ECU. Sometimes be careful, these do tend to get stuck. You can see that the one side has almost fully released. Just jiggle it a bit and you'll see that it will come free, and then you can go ahead and remove the rest of it. There you go. Then you can throw this in the bin and then install your newly purchased ECU. Depending on the ECU that you got, sometimes the ECUs aren't plug and play. For example, the ECU Master EMU Pro, the Black and the Classic are universal ECUs, so they will supply you, or you'll have the ability to purchase an adapter harness that allows you to adapt your factory engine harness to the standalone ECU. If you've built your own harness, if you've purchased a harness, do make sure that before you plug in the ECU, you go ahead and bust out the multimeter and you make sure that you have power where there's supposed to be power, you have ground where there is supposed to be ground. You know, we do make mistakes, people do make mistakes. It's always good to double check. The last thing you want to do is assume that someone has done their job properly. You know, the last thing we want is for you to plug in your ECU and then you end up frying it because someone made a mistake. I've never had an issue with the ECU Master plug-and-play adapters, so I'm fairly confident that once I plug this in, I'll go ahead and plug the ECU in, and I'll be able to go ahead and start building the Basemap and uploading any sort of sensor calibration that I need to. All right, so pretty much in reverse order, we'll go ahead and fit this in, and we'll start tightening the 10mm bolt. Do make sure that you do see even compression of the ECU header. You may have to jiggle it a bit, and there's no need to reef on it. You know, snug is good. And then we go ahead and plug in the ECU. Now, this particular ECU doesn't have an onboard map sensor, so I went ahead and I wired in my own onboard map sensor. You can see it's here. I ran a map sensor line from the intake manifold through the firewall and to this passenger side. We'll go ahead and plug it in. And at the same time, this already had an external wideband controller. I went ahead and installed a 2-pin DTM onto the output wires, and then I wired my own. As easy as that. These do require these USB to CAN devices in order to be able to communicate between the laptop and the ECU. Luckily, ECU Master does us a favor and they go ahead and pre-wire this for us. So we'll go ahead and grab our USB cable, plug that in. Now that this is all plugged in, obviously, as I said before, I'm very confident that there's power where there is supposed to be power, there's ground where there is supposed to be ground. Before you do any of that, do make sure that you take out the multimeter and confirm. Before you plug your laptop in, go ahead and plug the negative of the battery terminal back on. I see it more often than I like to admit. Guys will go ahead and give us a call, tell us that they can't connect to the computer, and it ends up being that they forget to plug the negative back on. So we'll go ahead and do that right away. Go ahead and install this terminal back on. Give it the gold wiggle test, and we're good to go. The next thing we're going to do is we're going to install a timing light in order to be able to sync timing before we even start the engine. This is a very crucial step before attempting to start the engine. It's an overlooked step by a lot of people out there, so we'll show you how to do it. You don't need the most expensive timing light. This is about $30–40 from your local parts store. And then this is a spark plug lead tester. This gets installed in line between ignition coil number 1 and then spark plug number 1. And we install this in order for the inductive pickup to have a really good signal, so the timing light goes ahead and flashes. Depending on the timing light, sometimes you can go ahead and install the inductive clamp on all the wires that lead up to ignition coil number 1. However, this is a foolproof method. This always works, and I would highly recommend investing in one of these. So we'll go ahead and remove ignition coil number 1, and then we'll install this right away. So on the 26s, these have 4 8mm bolts holding ignition coil number 1. We'll go ahead and remove coil number 1, put it on the side. This is the spark plug end. Go ahead and install that, make sure that's seated all the way, and then we'll install the other side into ignition coil number 1. Now, when you're done installing this, if you see that it's not seated, for example, you can see here that we have a bit of a gap. It's good practice to go ahead and put a rag underneath here so you don't have a short. You can go ahead and spend quite a bit of time fiddling around with this, not knowing why the timing light isn't sparking or isn't flashing. And it's because the spark plug energy is finding a direct path to ground. For example, if you've had unpainted valve covers or you had a bracket bolted somewhere. So we'll go ahead and just quickly put a rag. So we just have a microfiber. We'll go ahead and fold it. We'll just install it like this. And now we know we don't have a path to ground here when the ignition coil fires. Timing lights are very simple devices. You have 3 leads. One is ground, one is power, and then you have the inductive clamp. For guys that have relocated batteries in the back, typically you either would have a fuse box up front. If you don't, you can grab power from the alternator. Obviously this car has the battery up front. We'll go ahead and remove the battery cover, hook up power, and hook up ground. Now, the nice thing with this timing light is that when it is connected to power and ground, it does emit a bit of a noise. So I can hear that it is emitting a high-pitched noise. Now we move on to installing the inductive clamp. Most inductive clamps will have an arrow. This arrow points to the plug. So if you install this backwards, let's say this arrow faces the ignition coil instead of the plug, this timing light will never fire. So make sure that you are wary and you are aware that these are directional. In the event that yours doesn't have an arrow and the timing light doesn't fire, just go ahead and flip this 180 degrees and then you should be good to go. Before we move on to plugging the laptop in and opening the software, one thing you have to be aware is that your car does need a really good battery. Make sure it's fully charged. I've seen it a lot of times where guys will go ahead and attempt to start a car or start an engine and they can't, and it all comes down to inadequate battery voltage. So a lot of these cars tend to sit for quite a bit of time. It's good practice to go ahead and put the battery on a charger overnight. Most battery trickle chargers are relatively inexpensive, so it's also good to put the battery on a trickle charger so that battery voltage is maintained throughout the battery life. This has been on a battery charger for all of its life, so if you're not sure if your battery has adequate voltage, take out your multimeter, take the positive lead and negative lead of the multimeter, set it to DC volt, and just do a quick sanity check to see if you have adequate voltage. Most batteries, if they are good, will have anywhere between 12 to 12.6. If it's below 12, best to put it on a charger overnight, just so you have a solid battery before you start to go ahead and crank this engine and try and sync timing. Before you move on to, like I said, plugging the laptop in, always good to unplug fuel supply. So if you know where the fuel pump fuse is or the relay, go ahead and unplug that. We don't want to go ahead and flood the engine when we're syncing ignition timing. If the injectors are relatively accessible, you can unplug those as well. On this vehicle and on this engine specifically, it's got metal retaining clips that are a bit of a nightmare to unplug quickly. And I've worked on these long enough that I know where the fuel pump fuse is, so I'll go ahead and unplug that. That way I know that if the engine sees, or if the ECU sees a valid cam and crank signal, even if it does fire the engine or it does fire the injectors, it won't go ahead and provide any sort of fuel. Now that we have the timing light hooked up, we're going to go ahead and plug in the laptop, turn the ignition on, and I'll show you what you guys have to do in order to upload the Basemap, get the ignition timing locked, and set the timing so that there isn't any sort of discrepancies between what the ECU is commanding versus what we're seeing on the crankshaft. All right, so we've hooked up the timing light. We've made sure that the inductive clamp, in the event that it has an arrow, is pointing in the correct direction, and that is towards the spark plug. We know that we have adequate battery voltage. So now we have to go ahead and open the software for the ECU. Depending on which ECU you're using, obviously, will determine which software you have to use. We're using the EMU Pro. We're currently, as I said, testing one of their adapters on this R32 GTR. So I have the software pulled up here. I don't have the ignition set to on. With this EMU Pro, there wasn't a Basemap available, so I had to go ahead and make everything from scratch. With the EMU Black, the Classic, a Haltech Elite Series ECU, a Link, most ECU manufacturers will have a Basemap available, and typically it's either available on their website, or once you download the software, you'll be able to go ahead and file it or find it in your drive or wherever you downloaded the software. So we're going to go ahead and turn the ignition on. Most ECUs will either give you an audible sound or a visual representation that the ECU is actually on. So I'll go ahead and turn this key to the on position, and you can see now that the software has detected the ECU. It's telling me that it is connected. So now that I know that the ECU is on, we can either make changes to sensor calibrations, to the fuel map, ignition map, but for now I'm going to go ahead and show you what is required in order to sync timing. Depending on the ECU, obviously, sometimes it takes a bit of time to find where the ignition lock parameter is. Most ECUs will have a search function, including this one. So I'll just type in lock, and there it is. So this is a feature on pretty much every standalone. I mean, I should say every modern standalone. This allows you to lock the ignition timing value to a specific number, and then the ECU will go ahead and disregard any sort of corrections, whether it's a cranking correction, a startup correction, a warm-up enrichment correction. So we'll go ahead and enable this, and now you see that we have a lock value. Be careful, depending on what engine you're working on, what harmonic balancer you have. Some of the harmonic balancers available will only have a couple of marks. This one, for example, has an OEM harmonic balancer. The RBs have, I believe, about 7 notches. Each of those notches represents a ignition angle value. In the event that your harmonic balancer doesn't have a notch, or you're not sure, you can always remove spark plug number 1, rotate the engine by hand. You can fit a screwdriver inside of the cylinder, and then bring it up to top dead center on the compression stroke, mark your crank pulley, and you know that that's your 0 value. For the purpose of this video, I'm going to go ahead and lock it to 0. Before I forget, the EMU Pro, the Classic, the Black, you have to go ahead and save the changes to the ECU in the event that you key off and key back on. Some ECUs don't have that feature or that function. This ECU does have it. Now that the ignition angle is locked, we can go ahead and get a helper, crank the engine over, make sure that we have, if we're targeting 0 degrees of ignition lock, we actually see 0 degrees on the crankshaft pulley. If you don't have a Basemap available, and the firing order isn't designated, the ECU will never fire the ignition coils. And same thing goes with if the trigger settings, so if the ECU doesn't know what kind of crank trigger it has, what kind of cam trigger it has, the ECU will never be able to go ahead and fire the ignition coils, and the timing light won't flash. I've already gone ahead and populated this Basemap based on experience, so we'll go ahead and get a helper. He will go ahead and crank it for us, and then we'll be able to go ahead and dial this timing in. On most standalone ECUs, you can go ahead and change the TDC offset angle in order to dial your ignition timing in. So on RBs, SRs, you don't have to rotate the cam angle sensor in order to dial in the ignition timing. It's only there for factory ECUs. Most standalones will go ahead and have a value that you can adjust up or down in order to get it close. Once we have our helper, we need to make sure that we won't be injecting any sort of fuel. As I mentioned earlier in the video, you have a couple of options to disable fuel delivery, whether that's unplugging the fuel pump relay, unplugging the fuel pump fuse, unplugging the injectors. In my case, I don't really feel like removing fuse box covers. I know that the ECU is controlling the fuel pump fuse, or the fuel pump relay, sorry. So I can go ahead and completely disable the fuel pump. That way, when the engine is cranking over, the ECU won't apply a ground to the fuel pump relay and the relay won't turn on. So this value right here, this is the first TDC angle. This value right here is adjusted in order to get your ignition timing on point. So we have the ignition locked at 0 degrees. In the event I'm either too advanced or too far retarded, I will go ahead and make changes to this value in order to go ahead and bring the ignition timing close to my locked value, which in this case is at 0. Let's go get our helper. We'll go ahead and crank this over and dial this timing in. All right, so now that we have our helper, we're going to go ahead and aim the timing light at the crank pulley while your helper cranks the engine over. Colton, do you want to go ahead and crank? Again, please. So as you can see here, we're pretty much bang on 0 degrees. Okay, so we're cranking it right now, and you can see that the timing light is flashing. All right, so now that we have our base timing set during cranking, we can go ahead and continue with populating the base map. You'll have to go ahead and scale your injectors correctly. You'll have to go ahead and assign your outputs correctly, your inputs. So if you have a different intake air temperature sensor, if you have a different map sensor, a coolant temperature sensor, or you've added additional sensors like fuel pressure, oil pressure, it's a good time to go ahead and scale those accurately. I'm going to go ahead and re-enable the fuel pump outputs. I will go ahead and fire this thing up. I will lock the ignition timing to about 10 degrees. So the engine is happy when it's idle at around 10-15 degrees, and I'm going to go ahead and recheck my timing once again. So I have started the engine. I've locked my ignition timing instead of 0 to about 15 degrees. That way the engine doesn't struggle to idle. I will go ahead and shoot the timing light again, and you can see here that we are bang on. So the left mark, the blue mark, was our 0 mark. These indentations are 5-degree increments, so 0, 5, 10, 15. It is right bang on the 4th mark from the left. Now that I know my ignition timing is synced and set, I can go ahead and disable that and proceed with the calibration of the ECU. So now that we've confirmed ignition timing with the engine idling, I'm going to go ahead and remove the timing light, reinstall ignition coil number 1, and then proceed to doing some further checks. So now that we've synced timing during cranking, we'll go ahead and populate the base map with some critical information. This is also a perfect time to make sure that you don't have any sort of fuel leaks, you don't have any sort of oil leaks, coolant leaks. Just make sure you're careful when you do perform the first startup. It's always nice to have a buddy around that can look for leaks. Like I said, you don't want any sort of fuel leaks happening on the first startup, and oil leaks as well. we'll go ahead and move on to the laptop, and then we'll do the first startup here. So now that we've synced timing, we will go ahead and apply all the sensor calibration values. We'll populate the Basemap in the event that you don't have a Basemap available. I've already populated this with some values here. Make sure, like I said, you do have a helper that can check for leaks. We will go ahead and start this up. As you can see, this thing fired right up. I've already checked for potential fuel leaks, oil leaks, didn't have any of that. Now that you have an engine running, it is always good to make sure that it is not running too rich or too lean. You don't want to foul the plugs or potentially wash out any sort of oil on the cylinder walls. As you can see here, this thing is running a bit lean, which is okay. There you go, it's running pretty much on target now. Hopefully this was a very informative video as to how to upload a Basemap, what you have to do in order to get started. If you have any questions, feel free to comment on our video. We'll go ahead and try and answer them as quickly as possible. Now you're ready to book your dyno session with us, and we hope to hear from you. We've completed the ECU calibration on this R32 GTR with the brand new EMU Pro adapter for the R32. We were able to make about 322 wheel and about 280 foot-pounds of torque. As I mentioned, this is a bone stock car. The only modification that it has is an aftermarket Y-pipe. It's got an aftermarket exhaust. And then it has a fuel pump, so it made that much power at around 14 psi. We weren't looking to make as much as possible. We were doing this for testing and for educational purposes. Yeah, hopefully you guys enjoyed the video.